Hello guys, my name is Akash from BreVITy. Today we'll be looking at a type of tree traversal algorithm, the level order traversal. It can be used on binary trees as well as n-ary trees. So you may already be familiar with traversal algorithms like in-order, pre-order and post-order traversal. Level order is a little bit different than those in the sense that we will be needing an extra data structure to perform this. So let's look at what levels are first, taking a sample binary tree. So this is our sample binary tree where each node consists of at most 2 children and a minimum of 0. So our level 1 is defined as the root node of the binary tree, and the subsequent levels are the children of the elements present at the previous level. So level 2 will be composed of children of the root node. So it will be its left child and right child. So it is 7 and 5. The next level will consist of children of these elements. So they would be 2, 6 and 9. And the next level would be children of these three elements, which will be 5, 11 and 4. So this is what we mean by levels. And level order traversal means traversing one level after another. So first we would be looking at 2, then we'll be looking at 7 and 5, followed by 2, 6 and 9, followed by 5, 11 and 4 in that order. So that is what we mean by level order traversal. So to perform this level order traversal, we'll be making use of the queue data structure. A queue is a data structure that supports FIFO operations, which means first in, first out. So our queue would support pushing elements at the back of the queue and popping elements from the front of the queue. So this is a pretty normal queue and nothing special going on over here. So just a normal queue that supports pushing operations at the back and popping operations at the front. So now what does our queue contain? Our queue will contain the elements of one level of the binary tree at any given point in time. So to take an example, at the first point we'll be initializing our queue with the root element of the binary tree. So it would contain only level 1 elements. At the next point, our queue would have level 2 elements only, which are 7 and 5. And after exploring children of 7 and 5, our queue will contain only elements of level 3, which are 2, 6 and 9. And after that, our queue would contain only elements of level 4, which are 5, 11 and 4. So this is what we will be storing in our queue. So we first initialize our queue with the root element or the level 1 element. Now what you need to do is run a while loop until our queue becomes empty. Inside this while loop, we need to know how many elements are there at any given level in our queue. So the size of the queue will give us the number of elements present in that level. Using this information, we can now run a for loop from I is equal to 0 to size and explore each of those elements present in our queue one by one. And while exploring those elements, we can push on their children onto our queue if those children are not null. And inside that, we can do any operations that we want according to the question. So this is basically what level order traversal is. Let's look at the pseudocode and then solve a real problem. So we initialize our queue with the root element of the binary tree, which makes up for level 1. So now we run a while loop until our queue is not empty. So inside this while loop, we can get the number of elements present in that level by looking at the size of the queue. So as I said, our queue at any given point will contain only elements of one particular level. So to get the number of elements in that level, all we need to do is access the size of the queue. Using this size, we can now run a for loop from I is equal to 0 to size and explore each of those elements in that level. Now that first element would be the front of the queue because our queue supports first in, first out. So we'll be looking at the front of the queue. Now we pop the element from the front because we already have it stored over here. Then we push the left child of the node and push the right child of the node if they're both not null. And then we can do whatever code or operations that we want over here. So this is the basic pseudocode of level order traversal. Let's look at a problem to understand it better. Let's look at the problem now. The problem is binary tree level order traversal. We are given a binary tree in the sense that we are given the root node of the binary tree, and what we need to do is traverse this tree in level order fashion from left to right, as we have looked at the level order algorithm. So for this given tree, we'll have to traverse it as level 1, which is 3, level 2, which is 9 and 20, and level 3, which is 15 and 7. And we'll have to include all the elements of one level as a vector and push it onto our output vector. So our output would be a vector of vector int, and each vector inside our output vector would consist of elements belonging to one level starting from the first level. So the vector of vector would be 3, which denotes the first level, 920, which denotes the second level, and 15 and 7, which denotes the elements of the third level. So this is what we need to do. Let's look at the code now. So first let's understand the tree structure that we are given with. So we are given with tree node asterisk root, or a pointer to the root element, and this root element consists of a left child, a right child, and an integer value property. So this is our tree node structure. So using this, let's form our output. So let's define our vector of vector ints. So this is what we'll be finally returning. So before this, we need to do one check. So that is, we need to check if our root element is already null. In this case, what you need to do is return an empty vector. Now we need to initialize our queue. So our queue stores elements of tree node pointer types. Now we initialize our queue with the root element. So to do that, we just push the root element onto our queue. Now what we do is run a while loop until our queue is empty. So while not of q1 dot empty. Now we need to get the size of the queue. This size of the queue denotes the number of elements present in that level of the tree. So int s is equal to q1 dot size. Now using this size, we can now run a for loop from I is equal to 0 to the size and explore each element present inside that queue one by one, therefore exploring one whole level of the tree. So now the front element is now being used at or being looked at by us. Now we can safely pop out the first element from our queue because we already stored it over here and it is no longer of use to us. Now we need to store the value present in this node inside our vector, and to do this we'll have to declare a vector outside over here which stores the elements of one level. So vector int, let's say call it v1, and this v1 will store the elements of each level. So now that we have pushed this value onto our vector, we now need to push the children of this node onto our queue such that it can be explored in the next level. So if node.left. So what you're basically doing is we're checking if node.left is a null value or not. Because if it is a null value, there is no point in us pushing it onto the queue. So if it is not null, we push it onto a queue. Similarly, we check if our node.right value is also null, and if it is not null, we push it onto the queue. Outside this for loop, our vector v1 will now contain the elements of one level So for example, our v1 would now contain 9 and 20 if we were looking at level 2. At this point, we can push this vector onto our main output vector. So output dot push back of v1. So this is basically it for our code, and don't forget to return the output vector. So yeah, that's it for level order traversal. There are more videos coming up on level order traversal and binary tree in general. So do subscribe to BreVITy. So this is Akash. See you next time.